Hello there. Today we've arrived at Chapter 2 of the Planet of Wandering. I'm your good friend Curioscope, the Curious Mirror. Now, please follow my lens as we explore the mysteries of the universe. Have you ever thought about how the Earth was actually formed, and how it will be destroyed in what way? The story of the Earth begins with a vast spiral galaxy, the Milky Way. In an area 100,000 light-years away from that galaxy, there exists a large rotating dust cloud, as well as hot gas. This simulation attempts to present a scene spanning 50 million years, and in the vast expanse of cosmic time, it is merely a fleeting moment. In that period, millions of stars died in violent explosions. These explosion phenomena are called supernovae. They are displayed here in the form of flashes. They will constitute the matter of planets, scattered throughout the universe. Elements such as carbon, silicon, and iron. The energy released by a single supernova explosion, sufficient to cause the nearby star cloud to collapse. A large amount of dust and gas, gathering and pouring into its core. This nebula is considered the coldest existence in the universe. However, as the matter continuously accumulates, its density becomes increasingly high. The temperature also gradually rises. In the vast depths of interstellar space, a heart-stopping storm. In its core, it bursts forth rapidly. This is a scene filled with floating dust, thin gas, as well as the sparkling ice crystals, forming a huge and rampant hurricane. Within this eye of the storm, temperature soaring sharply. In that scorching high-temperature region, a star quietly ignites. Our sun is thus born, the energy source of the sun, originating from a slowly rotating disk. Inside this disk, it is like the cradle of the birth of the solar system. Within that mysterious and vast disk, the formation of planets undergone a long and intense process. At the beginning, faint dust gradually gathered to form sandy particles. They were in a relatively loose historical cloud, slowly coalesce into pebble-sized object. In the long river of time, after millions of years of sedimentation, the force of gravity gradually pulls these objects together. They collide and merge, eventually forming rock ice balls and boulders. These objects of various shapes continue to be pulled by gravity, condensed into microplanets. Among the numerous celestial bodies, there is a special planet, the primordial Earth. It is steadily growing. However, his fate was still undecided at that time, full of unknowns and variables. Once upon a time, we believe, the formation of planets. It follows a set of predictable patterns. Looking at our solar system, the nearly circular orbits of the planetary neighbors is the best proof. Not only that, there is also a clear division between gaseous outer planets and rocky inner planets. The gaseous outer planets include the majestic Jupiter, the mysterious and beautiful Saturn, the deep and cold Uranus, and the ice-blue Neptune, while the rocky planets have the scorching Mercury, the gentle Venus, the life-bearing Earth, and the resilient Mars. This clear division began to manifest shortly after the star ignited. The young sun produced powerful heat winds, like an invisible giant force, push the lighter hydrogen towards the outside of the disk. Gaseous outer planets, in absorbing the gas spewed by the sun, and grows rapidly, continuously growing. In this dusty, inner region lacking gas and ice material, became the birthplace of a rocky world similar to Earth. The discovery of a new generation of planet-hunting telescopes, astounding. A gas giant comparable in size to Neptune, usually roams in the internal region, shatters our understanding of traditional planetary distribution. Meanwhile, people also discovered a giant planet the size of Jupiter. The distance they orbit around the star is extremely close. The hot stellar wind is ruthlessly stripping away their gas. Besides that, there is also a category of large rocky planets. Scientists call them super-Earths. These mysterious planets, how did they cross all the obstacles to get there? Why are our own inner planets still so small? This series of questions have become mysteries that trouble the astronomical community. In fact, our understanding of the formation of the solar system largely comes from the study of these interstellar fragments. However, most of these tiny particles, when passing through Earth's atmosphere, disappeared due to intense combustion. Fortunately, some larger ones survived during the fall. Scientists, by measuring the changes in molecules called isotopes, conducting in-depth analysis of these precious planetary fragments, research found these debris seem to come from the inner and outer solar systems, forming two different asteroid groups. This indicates that there must be some mysterious force between these two regions, creating an insurmountable barrier, preventing objects from freely mixing. If this huge boundary line is the Jupiter of youth, then his growth rate at that time must have been astonishing. He would be like a barrier, cut off the channel for material to flow into the inner solar system, thus hindering the formation of large rocky planets, or super-Earths. Jupiter in the long history of our solar system will forever be in the most influential chapters, playing a core role. Its role and significance are profound and substantial. Scientists use supercomputers through the dust gas, in-depth study of the interaction between ice and boulders. The formation process of Jupiter was successfully simulated. In this simulation process, every moment of accurately corresponds to a collision event. Every circular trajectory clearly traces the orbit of a future planet. Under specific conditions, the giant Jupiter gradually forms its unique orbit in the outer region, rendered in blue. Over time, Jupiter continued to grow. Then, it begins a spiral trajectory towards the Sun. Scientists, the significant change of Jupiter in this process is called the Great Turning. This name originates from the state of a sailboat sailing against the wind. During the Great Turn of Jupiter, he passed through the debris clouds scattered throughout the universe. The matter that could not be devoured by Jupiter was thrown out of the solar system. As Jupiter continuously approaches the Sun, simulation tracking results show Jupiter has been moving to the orbital position where Mars is currently located. The Great Migration of Jupiter, further significantly reducing the mass of the inner solar system, leading to the current region of the inner solar system. Any planet formed, its mass is relatively small. As time continues to pass, another equally massive planet, Saturn, gradually grow to a sufficiently powerful level, thus generating enough power to pull Jupiter's orbital path back. In the Earth at that time, in the universe, it is merely the embryonic form of a future planet. With the departure of Jupiter, Earth, and dozens of other celestial bodies in the evolutionary stage, have obtained the opportunity to freely compete for remaining matter in the inner solar system. Whether they survive or not completely depends on the accidental factors in the universe. After forming within the solar system for 50 million years, the competitive situation between planets, similar to a roller skating race, became extremely intense. Due to the remaining planets pulling and tugging at each other, their orbital paths gradually lose stability. Collisions between them become inevitable. Ultimately, in this intense process of cosmic evolution, only a few possible worlds remain, including the major planets we know today, and at least one other planet still exists. The existence of this planet came after a very famous milestone event in the history of human exploration was confirmed through a series of scientific inferences. July 16, 1969, Apollo 11 successfully launched into space the United States heavy-lift rocket, Saturn V. After undergoing 13 launch missions, successfully and safely delivered the payload to the designated location, Apollo spacecraft. It has landed 6 times on the cratered surface of the Moon. 12 astronauts step out of the lunar landing module. During close-range immersive experience of the lunar environment, a series of scientific activities were carried out. Various experiments were conducted, conduct precise measurements, and, during the journey of walking or driving across alien terrain, collect lunar rock samples. When the astronauts return to Earth, the whole world cheers and rejoices. They are the first and so far the only batch to have left Earth and successfully logged in as Earth humans from another world. At that time, almost no one predicted the rock samples they brought back from the Moon to Earth would trigger discussions about the Moon and Earth, a series of major scientific discoveries. After returning to NASA's laboratory, scientists conducted in-depth research, discovered the Moon rocks and Earth rocks share many similarities. Particularly noteworthy is, they have the same oxygen isotope forms. This feature, a unique identifier for celestial bodies in the solar system, as significant as blood types. Judging from the features on the lunar surface, the Moon is covered with huge ancient craters, and it is surrounded by concentric rings. By NASA's Moon Mapping Orbiter, in the recently taken image of the Eastern Sea, it can be clearly observed that these landforms are. The call for these concentric rings indicates, in the evolution of the Moon, there was once a massive impactor struck on the surface of the scorching liquid in a rolling state. Subsequently, ripples spread outwards. The astronaut near the dew point discovered scattered relatively light rocks. These rocks are very likely to be exposed to the surface when heavier materials sink into the magma under compression. Furthermore, they also discovered some rocks later nicknamed as Transformed rocks. The composition of these rocks includes potassium, rare earth elements, and phosphorus. These rocks are called plagioclase. They are products of a molten surface. As for why the moon formed a lava ocean, and the connection between it and the Earth, the most widely accepted theory, that takes us back to Earth about 4.5 billion years ago. At that time, there might have been volcanic activity on the Earth's surface, and it had a thin toxic atmosphere. The Earth at that time was in the late stage of planet formation, awaiting the major tests of the birth and evolution of subsequent life. In the vast expanse of space, there exists a planet. Its size is about half the size of another planet. It is gradually approaching this planet. This planet is Theia, a unique world that once could have coexisted with the planet we inhabit in the course of cosmic evolution, where we currently reside. However, the trajectory of the universe's fate is not like this. When Theia and our Earth, during a violent collision, his own journey came to an abrupt end here. Do not hesitate to imagine, when this ultimate threat gradually approaches the horizon, from the perspective of the Earth, what a shocking scene it would be. The impact of Thea's second, like a huge storm in the universe, deeply shook the core of the Earth. This impact was extremely fierce, even cut off the Earth, 1/3 of it. But surprisingly, Theia did not completely destroy the Earth. Instead, it gradually merged with the Earth after the impact, becoming an integral part of the Earth. Through advanced computer simulation technology, we are able to capture, in the first 24 hours after the collision, that heart-stopping scene. In this earth-shattering impact, the vast amount of debris released heavily enveloped the Earth. A dense atmosphere formed by vaporized rock, extremely thick. Over time, these fragments gathered into huge clouds, gradually coalescing into a molten debris belt emitting scorching light, most of which are orbiting the Earth. These debris, like dense raindrops, falling back to the Earth's surface in scattered manner. But what's amazing is, in just 1 century of time, the remaining fragments even ingeniously converged together, formed a wonderful and spectacular celestial body that is the faithful companion of Earth, the Moon. Following the Theia impact event, our Earth began the process of rapid rotation. The tilt angle of its rotation axis compared to the past changed slightly. At that time, the orbit of the Moon compared to its current position, closer to Earth. Thus, the huge and bright surface of the Moon almost fills the entire sky. As the Moon moves under the influence of gravity, it gradually slides into a farther orbit. It exerts a certain resistance on Earth. Under the influence of this resistance, the Earth's rotation speed gradually slows down. At the same time, its axial tilt also gradually stabilizes. The Moon is not just a cold satellite. Even more so, we are the loyal witnesses and memory bearers of that great catastrophe that nearly destroyed the entire planet in the history of our Earth. However, from that distant past, continues to this day, the Moon has become a reassuring part of our lives. In a popular place, it symbolizes the source of stable power to bring us endless peace and harmony. At the same time, unique radiance falls upon the Earth. It also forms an unparalleled beautiful picture, but it must be pointed out that, in the vast history of the universe, violent events have far from subsided. Unlike Earth, the Moon, due to its unique geological structure, erosion, as well as the traces of geological events on its surface, preserved relatively intact. The marks of vicissitudes from distant past, not completely erased, while the Moon faithfully records a series of impact events that followed, like an ancient history book, vividly describes about 4 billion years ago. A magnificent history that unfolded in the solar system. That was in that distant and mysterious period. Jupiter and Saturn, in the complex gravitational environment of the solar system, produced violent changes towards the inner solar system, launched a large number of celestial bodies. These celestial bodies are like bullets in the universe, flock to various celestial bodies within the solar system. Initiate the assault. To gain a deeper understanding of that history, scientists conducted a research of great significance. Researchers, according to the Moon, the size and number of numerous meteorite craters, through precise scientific computer models, a simulation of the impact that the Earth suffered at that time was conducted. The research results show, in those turbulent years, the Earth has experienced at least 4 massive impact events. The energy of each impact, all of which are capable of reshaping the Earth's surface features, fundamentally altering the course of Earth's historical development. During the impact process, these massive celestial bodies surged forward with overwhelming force, striking in the uranium and potassium-rich on the Earth's crust, powerful impact, causing these elements to be violently torn from the Earth and propelled into the vast expanse of space. In the field of geology, people call this complex and spectacular process impact erosion. The immense energy generated by the impact formed a layer of molten outer shell on the Earth's surface. When the intensity of the impact activity eventually gradually weakened, this outer shell cooled down rapidly due to its high heat dissipation rate, can cool more quickly, and in the gaps of the impact, those relatively smaller in scale, but numerous impact events, carried a large amount of water vapor into the crater. Partial impact also promotes the close combination with deep subsurface minerals of water, gets released in this series of events following one after another. Under the continuous impact, in the 500 million years after the birth of the Moon, the Earth gradually evolved into a water world, that vast and boundless ocean, like a huge blue silk, covering the entire horizon. Occasionally, only a few resilient volcanic islands dot the landscape, as if they are solitary guardians of the Earth amidst the sea. The Moon continues to orbit around the Earth in a geosynchronous orbit. Its gravitational pull raises the tides. It creates a strong impact on the rocky volcanic coast. Earth's atmosphere is composed of a mixture of hydrogen, nitrogen, and carbon dioxide, and mixed with water vapor. Land and ocean are rich in carbon, various chemicals such as ferric nitrogen oxide, and these substances all were produced when the solar system was born. Earth has already possessed all the conditions necessary to accomplish its most ultimate feat, to nurture life. However, there is a problem in this. The Earth's water resources are gradually decreasing. At that time, the young sun, its brightness, though not as great as today, but it is very easy to produce strong flare phenomena. These flares hit the Earth's upper atmosphere. When the sun particles hit water molecules, they will blast them apart. Among them, the light hydrogen will drift into space, while the relatively heavier oxygen sinks to the Earth's surface and combines with rocks. Now we have become clearly aware. What severe consequences will this process trigger? By observing spacecraft, we can see Mars in the distant past once had abundant water resources. Its surface is carved with the winding paths of ancient rivers and is covered with the deposits of lake and ocean beds. In the present-day Mars has already become a lifeless planet. Its atmosphere now only consists of a thin layer of carbon dioxide. With the help of special sensors equipped on the orbital spacecraft, it recorded the continuous loss of water resources on Mars due to solar radiation. Scientists have already discovered life on Earth's sister planet, Venus. The same process was observed. The atmosphere of Venus at present, packed with various toxic chemicals. The thick sulfur clouds are also one of its components. In the atmosphere of Venus's surface, carbon dioxide concentration is extremely high. Carbon dioxide as a powerful greenhouse gas can absorb the heat of solar radiation, making Venus like a blazing cauldron. The surface temperature of Venus is nearly 500 degrees Celsius, the hottest in temperature among the major planets in the solar system. Active volcanoes scattered on its surface further worsen this harsh environment. Continuously erupting sulfur and carbon dioxide bend the Earth. How can one avoid falling into such a tragic situation? First, Earth has Venus and Mars, the protective shield it lacks, the magnetic field, which can deflect the strongest radiation waves from the sun toward the Earth. This magnetic field is caused by the heat exchange phenomenon between the Earth's core and the crust. This is merely the Earth's first line of defense. As early as 4 billion years ago, another part of the Earth's surface, the defense line, has begun to form. Long-standing theory has believed heat and chemical reactions have given rise to proteins and nucleic acids, these two key chemical substances that constitute life. Recent views indicate hot springs were widely distributed on the early Earth's land, as well as other volcanic landforms. However, no one has yet known for certain how life began, nor where it first obtained its foundational development. What we do know for sure is that life indeed came into being, and with a key breakthrough, the ability to convert sunlight into energy, it has been able to proliferate widely. Photosynthesis, the process by which this plant life survives, first appeared in simple bacteria over 3 billion years ago. Scientists, using one of the most powerful supercomputers in the world, attempting to unravel the chemical mysteries of photosynthesis. In the initial stage of photosynthesis, the primary task is to capture sunlight. sunlight passes through a transparent membrane to reach the center of the bacteria. A cluster of spherical pod structures can be seen here. Each spherical pod is equipped with specific sensors for collecting solar energy. When photons strike, they excite the chlorophyll molecule ring. This energy is passed sequentially through the protein family, electrons and protons. Energy is transmitted through a series of chemical reactions, and the energy from these reactions comes from the sun. At this moment, cells need to convert this energy into actual movement. Energy stored in protons drives objects to move. They flow into the space of water within cells, chasing towards towering molecular structures. When these protons flow in, the charge it carries will make the protein turn like a crank. The chemical reactions triggered by this rotation affect all life on Earth are of great significance. Two molecules combine, forming a third molecule called ATP. In the relevant display, usually presented in blue, ATP is present in every cell that has ever lived. Universal energy currency, like a biological battery, can store the energy captured from the sun and reorganize it into a stable form to be used by cells to break down food and drive movement, to provide energy for reproduction and maintain life activities. The emergence of ATP allows microorganisms to reproduce continuously. As bacteria evolve to produce plants, a more advanced stage of photosynthesis will produce a byproduct called oxygen. Newly generated free oxygen, the amount exceeded the absorption capacity of land and sea. In the atmosphere, it combined with hydrogen, prevent it from escaping into space, generate new water molecules at the same time. This process gradually slows the trend of Earth's oceans drying up, but it cannot completely prevent. According to a recent study, the Earth currently still loses up to 25% of its original water reserves. On the Earth's surface, water life, the sun, and geological activity work together to power an extraordinary planetary engine. Climate change, to some extent, it is due to the day and night cycle, as well as the changes of seasons causing the uneven heating by the sun causes. These factors regulates the global temperature of the Earth, drives warm equatorial wind belts toward the poles, blows cold polar air toward the equator, tides and ocean currents, mixing cold deep-sea water with warm surface water, solar energy and carbon dioxide destruction, Venus's greenhouse gases, trapped in the atmosphere together by water vapor. The key factor in controlling carbon dioxide emissions is the unique life on Earth. The oceans are filled with white crocodiles, tiny floating plants that can absorb those carried into the sea by waves, or drawn from the deep sea by ocean currents, absorbing carbon dioxide from the ocean. Afterward, they will transport carbon atoms to the upper part of the food chain. Phytoplankton become food for zooplankton, such as radiolarians. These organisms date back 500 million years. At that time, life was in the oceans of the Earth, the period of vigorous development. From the perspective of classification level, molluscous animals, they belong to tiny arthropods similar to crustaceans. They are also the largest source of protein in the ocean. Octopus larvae is members of a vast ecological community. Even its body size is smaller than that of a human fingertip. Plankton are preyed upon by small fish, and small fish become food for even larger creatures. At every link in the food chain, carbon, initially as part of the diffusing gases in the air, will be passed on to increasingly larger animals. Under normal circumstances, the larger the size of an organism, the greater the mass of carbon it contains. From whales to tiny plankton, marine life are all important components of the global ecosystem. This system can absorb carbon dioxide from the atmosphere, then gradually release it back into the atmosphere. The key to the carbon cycle lies in the Earth's ability to store carbon long-term. A satellite of the National Aeronautics and Space Administration, NASA, is conducting chlorophyll monitoring. Chlorophyll is a substance that can be used to monitor plant growth conditions. Chemical missing agent. With the change of seasons, plants absorb large amounts of carbon dioxide and release oxygen for us to breathe. On land, when plants and animals die and decompose, carbon is transformed and enters the ground. The Earth itself is also involved in this process. When it rains, exposed rocks absorb carbon dioxide, and erosion then carries them into the ocean. If they contain carbon-rich substances, becoming part of the ocean food chain. Over time, carbon-rich sediments may transform into oil, or form rocks such as limestone. Once these sediments, material exposed on the surface, or affected by volcanic activity on Earth, Carbon then re-enters the environment. Every year, carbon dioxide emitted by volcanoes into the ocean and atmosphere exceeds 100 million tons. The effectiveness of the carbon cycle in forming Earth's habitable environment, of great significance, depends on life phenomena on Earth. The Earth today has vast and boundless oceans, a complex and ever-changing atmosphere, as well as extensive solid land, illuminated by sunlight, warm and pleasant. A life of abundance has been formed, and suitable habitats for ecological balance. When we delve deeper into the Earth, the operating mechanism of this complex system is nothing but admiration for the precise coordination and synergistic effects required for its operation. The impact left by the supernova explosion, Jupiter's strong gravitational effects, an accidental celestial collision, and the birth of the Moon. These factors collectively contributed to the formation of water resources and the birth of life. The more capable we become at reconstructing Earth's past evolutionary history, the more we will discover. This process is filled with wonderful characteristics. We gradually realize that there are countless other star systems in the universe, and thus we can't help but ask, is the Earth merely one among many inhabited, habitable worlds, or is it a unique existence under extraordinary circumstances? Our Earth is like a paradise, but is it the only paradise in the universe?